So I'm Richard Maines, but my company is Maines Associates, and I'm the moderator of this panel. And I'm kind of wearing a NASA Flight Opportunities hat here at this event, partly, which is the technology liaison for that program, kind of brokering between the NASA program and the research community, and we solicit research payloads into our program, and NASA's finds high priority based on their technology and their interest in using them in future missions, and then we buy rides on these commercial vehicles, including the X-Core vehicle, which if you were here yesterday, you had a very nice profile on. So anyway, that's one hat I'm wearing today. I'm wearing a moderator's hat, and if you have your agenda in front of you, we list the speakers, and the focus of this panel is really a Q&A. We've got folks here that these presentations were given yesterday on the X-Core vehicle, Ed Wright covering citizens in space, and Mano Sharma just had to bail here, but Brian Rieger, his partner at Unfunded Aerospace down here. I may as well introduce people. Okay, so Brian Rieger down there at the end, in Unfunded Aerospace, and the Ardulab technology gang. And they will be doing more this afternoon on that. Brian Campins representing X-Core here today. Kaki Rodway was here yesterday, but she had to head back to her post. And Owana Marku, we have a spelling error here, I guess, is here from the SETI Institute and NASA Ames, and is an expert in microgravity, biosciences areas. I guess that's it. So the focus here is using these folks, and I can join in on this, and I may ask some questions myself, and trying to really handle questions that have come up in your minds from yesterday's activity, or anything you might like to ask people on the panel, or even bring up as a topic that maybe hasn't been addressed. And I guess the first question I've got, how many people are here today who were not here yesterday? Okay, just only a couple. So that's good. So at least you've got, and we can try to expand on what happened yesterday, when the panel's over. So, just a quick statement, I guess, and my impression of, all the extraordinary stuff I heard yesterday. The focus really is on, at this workshop, is the Citizens in Space, opportunity that got lined up with this wonderful collaboration with the X-Core vehicle, and this capability to fly, small Cube Lab size payloads in the carrier behind the pilot, and opening up the door to development of those payloads to a wide group of people who may be experts, all the way to people who've never done it before, to participate in space, as well as the opportunity that Ed Wright is providing for people to be selected to fly in the co-pilot seat. And all of that was discussed in some detail yesterday. So I'm going to open up the floor to any questions. Yes?
I just wondered if you could give an overview of the range of flight opportunities and the different things they would have to go through. From on the X-Core side, you have, if you have the money and you pass a safety check, you can fly it on the NASA flight opportunities. It's peer reviewed, sponsored, and then Citizens in Space is somewhere in between. So I was wondering, just to give a feel for, who approves your payload in that sense.
Well, I could take a stab at that, but I very much want Ed's view on this. In fact, I haven't even had a chance he and I, to talk about this. It's one of the topics I was going to talk about this afternoon. But
can you repeat the question?
Let's see if I can try to do it. I'll simplify it and just understand it. I think you were trying to understand the potential interaction, if there's any, between perhaps applying to NASA's Flight Opportunities Program and receiving funds to fly on a vehicle with some kind of technology payload, and how that might relate to an opportunity that would come up to fly a payload through the Citizen Space X-Corps program. Do I have that right?
Yeah, and then on the far side is, if you just show up with money to export, no one else approves it.
I think if you showed up with money to X-Corps, you would be welcomed. 3 cheers from the staff. Let me just give you my take on this, and I very much want to hear Ed's. The Flight Opportunities Program has 2 major mandates that drive it, and are the rationale for funding it. One is to competitively select technology payloads that get proposed to it, and one of the big selection factors is whether or not the technology that's proposed aligns with a high priority NASA technology need. Secondly, the technology has to be at a level that it could be adapted and modified and, say, customized for something like, say, flying on X-Corps or some other kind of vehicle quickly. So it has to be advanced enough to be turned into a safe payload. And the other mandate is really by buying rides on all these different kinds of commercial vehicles, helping stimulate that market, so in fact this all can continue to work. And to really open the door for, just as you say, for somebody who's got a payload they want to fly and they've got the dollars to pay X-Corps, X-Corps flying. They got a pre-flight, post-flight ground system, how to get payloads into the system. They know what it's going to cost. They've got payload integrators to support that activity, and so it's stimulating the industry as well. Now, Ed, I'm gonna pass this on to you because I don't think you people can really hear it. But what's your view of this?
Okay. Well, first let me start off with a little compare and contrast. I think that what we're open to flying is a bit more flexible than what the Flight Opportunities Program is currently looking for. We are not necessarily looking for a technology which is aligned with any specific NASA mission. It does not need to be at any specific technology readiness level. And we are also open to flying pure science payloads as well as technology payloads. So we have a bit more flexibility there. The other area where we have more flexibility is that the Flight Opportunities Program is operating under this policy which comes from the top level of NASA headquarters, which says that they cannot fly any payload which specifically requires and involves a human payload operator on the vehicle. And we are not subject to that restriction whatsoever, and in fact, we intend to fly payload operators on all of our flights. And I would hope that in the process we might even provide some incentive for Congress and NASA to look at changing their own policy on that. In terms of what we're looking for specifically in payloads, we have some very general guidelines, and as long as your payload meets our guidelines and you submit hardware which looks like it has a reasonable chance of working, we'll fly it. We're looking for payloads which are legitimate citizen science experiments, which means that they're actually contributing some sort of new knowledge to the human race and not just textbook demonstrations of something which everyone is really pretty sure beforehand is actually going to work. We're not looking for a payload where you're experimenting to determine will water boil in microgravity, because everyone knows that it will. It can be a replication of a previous experiment, as long as it's something which legitimately requires reconfirmation of previous results. And we are looking for payloads that can be reproduced by other citizen scientists, which means that everything we fly will become open source hardware. Our definition of open source is fairly flexible. We're not religious about open source. You can use proprietary commercial components in your payload as long as there's something which other people can go out and buy. We don't want any unobtainium or one-of-a-kind parts which other people don't have access to. What we want in terms of open source is enough documentation that other people can replicate your experiment, as well as an open source license which allows them to do so.
You asked a very good question. And just back again, I'll take the moderator's right to the microphone here. It's my view that the Flight Opportunities Program, which has been flying intensively parabolic aircraft flights, which are available. These vehicles are not flying yet. We're flying some on balloon flights. We're flying one sounding rocket, second flight coming up this month. So we're just getting into the suborbital reusable launch vehicle up to 100 kilometers, up to near space mode. But we've been flying intensively about 4 parabolic aircraft flights every year, filled, and the demand for that is very high. Of course, you can bring people on board. There are very few limits in the size or weight of that payload. You can release portions of that payload up into during a short microgravity period, and actually have a free float. You got great video capabilities on board. You got at night you can modify the payload for the next day's flight, so you have multiple flight days. So there's tremendous value in these old traditional parabolic aircraft flights. It's my view that the shift of payloads to SRLVs is going to be a very, very significant shift. The payloads have to be automated. The ones that go in the X-Corveille, mostly vertically automated. They have to be much smaller. They have to be much lighter weight. There simply isn't room for them. Compared to a great big commercial aircraft, you can put almost anything in there. So the smart, small, low-cost, sort of data-intensive, all your data systems also have to be totally automated. So the pre-flight work is going to have to be really smart. The post-flight data dumps are going to have to happen real fast. That environment and that shift to the SRLVs is going to really drive these kinds of technologies, and this is why Ardulab and Unfunded Aerospace is such an exciting group to have here. And it's my view that the commercial subsystems that are emerging from this market, from these kinds of providers that can fold in for other researchers to use, are going to be absolutely essential as we get into SRLVs, because no one's going to rebuild a complete payload from scratch. And use every commercial component you can possibly use and lower your cost and do it cheaply, and then add your particular unique technology capability. So that's why I'm here. I mean, I think this is just a phenomenal mix, really, of opportunity. More questions? Yes?
What about the data collected, accessibility to it? You have it in a database, or is it proprietary data, or how's the data collected from this experiment?
Well, I can tell you about Flight Opportunities. I've been actually involved in that. And Unfunded Investigators turn in final reports. There's a format for that. It's sort of a standard kind of requirement for NASA funding. And then we extract information from that can be publicly released, and sometimes it can't be. Made in Space, for instance, is a classic company, a company with a lot of proprietary interests in their customized printer that they're working on. So, but certain elements of that then go right up on our website. Our Flight Opportunities website, as much as we can. So we're profiling results as much as possible, and we're actually now beginning to write up some of those technical results for much broader understanding and feed those into NASA headquarters, and we'll get those also on our site. We just wrote a paper summarizing some of the results coming out. But that's one of the things you get out of a NASA program, and I'll let Ed answer that from Citizens in Space.
Okay, well, first of all, I'd like to correct something which Richard said. We are not going to require all of our payloads to be fully automated. We do expect to have a payload operator on board. And we are also hoping that we'll have the capability for the payload operator to control some of the payloads via a Wi-Fi connection. It's not entirely certain whether X-Corps is going to allow Wi-Fi devices on board. They're not certain themselves yet. I've talked to Eric Anderson, the X-Corps engineer who is working on the avionics. I've actually known Eric since he was a first lieutenant in the U.S. Air Force, so we go back many years. And X-Corps thinks that Wi-Fi devices are probably going to be acceptable aboard the Lynx, although they haven't done any sort of testing yet. The way the Lynx is designed, if there is interference with the primary flight instrumentation system, they have manual backup. So what happens at that point is that some of the primary instruments will be interfered with, and they simply abort the mission and return to launch site. And if that happens too often, they're going to say, hey, there's a problem here, you can't fly this thing again. So we are currently operating under the cautiously optimistic assumption that we will have Wi-Fi capability available, so in which case the payload operator will have some sort of Wi-Fi device, perhaps an Android phone or an iPhone, and be able to control the payloads from that device. As far as data distribution is concerned, we are very committed to the ideals of open science, so we intend to have a section on our website where we make all the data available to the public, or perhaps we'll partner with some other organizations such as Popular Science or Make Magazine or some other organization to actually make the data available through their website. We don't insist on necessarily doing everything ourselves.
Yeah, thanks for those comments. The Flight Opportunities Program has some potential constraints on it related to interacting with those payloads that really are not defined yet. And I think that Citizens in Space and X-Corps is definitely going to ferret out the kinds of interaction you might have with those payloads during flight. Von Kegel has joined us down at the end of the row from Human Life Sciences program, Astronaut program, and was here yesterday, so she can join in the discussion. Are there any more questions from the audience? Anything? Yes?
I don't know enough about your system yet, but if you remember, there was Artemis, the common lunar lander, and what they were trying to do there was to provide common services to all the payloads.
Yeah, I'm going to hand this to you. You're close enough, so I think.
Okay, thank you. Yes, I was asking about the payload interfaces you have. The common lunar lander and Artemis, they were looking at common payload interfaces. So they would provide the voltages for all the experiments, they would provide cooling, they would provide instrumentation or telemetry, etc. You're going to do those kinds of things so that the payloads can be integrated to get a better, make it easier on the experimenters.
That's a great question.
Okay, I can answer that question. Our interfaces are going to be very, very simple. We are looking for 1U and 2U CubeSat form factors, which is, a CubeSat is 10 centimeters on each side. A 2U CubeSat is two of those put together, 1 or 2 kilograms respectively. We're actually not using the term CubeSat because when I start talking about CubeSats, it tends to confuse people. They think we're talking about free-flying satellites, and they think they need to conform to all the electrical specifications in the CubeSat spec, which are completely irrelevant to us. So we're actually referring to these as Lynx Cub payloads. Lynx Cub being a play both on CubeSat and on Lynx, obviously. We thought that was kind of a cute name for it. As far as the interfaces are concerned, we will provide you with an on-off signal. We will also provide a power connection, and we're going to do the power connection in a couple of ways. You can choose between them. There will be a 2.1 millimeter center positive barrel connector, and there will also be a USB power connection. And I emphasize USB power. It's not a data connection. It simply will provide power to your experiment. The USB spec gives you a lower amperage than the barrel connector will. X-Corps provides us with a limit of 100 watts of power for all the experiments, and we expect to fly 12 experiments per flight, so you can divide 100 by 12, and that gives you your maximum wattage. There's a 200-watt limit on thermal dissipation. So the difference between the 100 watts and the 200 watts will be any extra batteries you have on board your experiment, as well as any biological or chemical reactions that are producing additional heat. We're not providing any sort of data collection. We thought about that, and it very quickly came to the conclusion that it was pointless. If you need to collect data, it's very easy to add an SD card to your experiment. It adds almost no weight, it costs almost nothing, and frankly, you know, if we were to add a data connection, the wire runs for the cable would probably add more mass than that SD card does. So there didn't seem to be any advantage to a flight of this duration. That having been said, if you actually need a data collection for some weird reason for future programs, we are going to make the Lynx Cub payload carrier available as an open source hardware design. So future experimenters will be able to customize the payload carrier for whatever additional needs they have in terms of data collection or anything else they want to do with it.
Brian, you want to make any comments on that, or any thoughts? Brian Rieger from Infinity Aerospace.
Yeah, I think, well, if you're going to step from, say, you know, the suborbital regime to the orbital regime, the USB spec is sort of standard on the orbital. So, for example, you're going to fly with nanoracks, the USB port is the standard there. However, like I said, if you want more power for the suborbital flights, you will need that barrel connector. Now, the USB in power mode, as you mentioned, is not limited by the half amp draw that normal USB 2.0 is from your computer. Say it's limited to 5 amps. So you can draw up to 5 amps through the Lynx Cub with a USB connection.
Thank you. Any more questions? Thoughts? Yes.
Just a quick follow-up. That's 5 amps per module connected, or 5 amps total for the whole unit?
So
per
each
experiment
USB port can take 5 amps.
on the Ardulab.
Okay, the Ardulab is a different story. This one's designed for space, but the USB standard, if you will, for non-data use can go up to 5 amps. If you're using it in a charging capacity or purely power capacity.
That having been said, keep in mind if you're using a microcontroller such as the Arduino or a microprocessor such as the Beagle board, they also have limits on how much power they can pass through them. So you need to check on what hardware you're using as well, and not just assume that the amount of power you can pass through is equal to the amount of power that we can provide.
Questions? Yes. I think there was one. Yeah, there's someone back there. You go ahead and ask your question. Way in the back. You're next. You want to come up?
Yeah.
All right.
Okay, so you know me, I'm Rick. So a couple of questions. One is when does the power get turned on the Lynx Cub? Is it on the ground or is it somewhere up in flight? That's one thing. And then I'm also thinking about for if you want to put there's a couple of positions on the outside of the vehicle, right? Where someone could put experiments. When would the power be turned on that? And things of that sort.
Ed?
Normally, the power would be turned on just prior to launch, and since we're flying multiple payloads and you know, having to turn on 12 payloads individually is a bit of a chore. So what we would recommend is that by default you plan for your payload to start receiving power just before launch, and then have some sort of timer to determine when you actually want to start collecting data or performing any processes that you're going to be performing in flight. Or another way would be to have an accelerometer so that you can determine when the G-forces fall below a certain level, so you can start doing your microgravity work. Again, you know, we are hoping that we will have this Wi-Fi capability as well, in which case we will be able to turn payloads on at a specific point during the flight. But it also will be a fairly high workload for environment for both the pilot and the payload operator. So anything you can do to make our life easier is greatly appreciated.
Thanks, Ed. Just one more question. What a concept.
I'll just holler. Just wondering if data from the spacecraft itself will be available to experimenters to correlate or back up instrumentation into their own experiments.
Yeah, you have a whole system for that, don't you, Ed? Yeah. He thought of that.
The links will be collecting flight data during the flight, and it will be available to experimenters after the flight, which means that you can then compare and correlation afterwards in your post-processing. We actually had some discussion as to whether there was a benefit in making that in-flight data available to the experiment during the flight, so that the experiment microcontroller would have access to things like GPS data, and we didn't see any great advantage of that. I mean, it might help certain experiments, but it did not seem to be worth the trouble which would be necessary to provide it in the, at least in the first version of the Lynx Cub payload carrier.
I don't think that Jeff will want any experiments messing with the avionics or anything like that, so it's most likely going to be no connection at all.
Just by the way, this is Nadir Bhagavayev. He's one of our engineers at XCore.
Yeah.
So you want to stand up and...
Hello.
Thank you. Thank you.
So it's most likely that there are going to be no connection to avionics of the vehicle, and avionics themselves are kind of a redundant system. You can fly completely manually with pretty much no electricity. So I don't think there's going to be any connection between avionics and payloads.
I wasn't paying as much attention as I should have been. Were you saying, Ed, that there will be systems on board connected with the payloads that are monitoring, gravity levels, temperature, vibration, just ambient environmental factors? Here. Yes, right.
Okay, I know what Richard is alluding to right now. No, we are not planning on providing any connections between the vehicle avionics and our payloads. What Richard is referring to is during the flight test program, we're actually going to be flying the Lynx Cub payload carrier. We will have our hardware ready to fly by this September, which is roughly the time frame when XCore is hoping to be able to start flying the Lynx. And at that time, we will begin flying the payload carrier, which will be loaded up with a lot of instrumentation which we provide, which will be collecting baseline data, which we will then make available to the experimenters to help you people with the design of your own experiments. So we will have accelerometers, we will have gyroscopes, we will have thermal and pressure sensors, we will have radiation sensors. So we'll be able to provide you with the complete profile of the flight environment at every point during flight. So you'll know what the thermal profile for experiments is like, you'll know what the acoustical profile is like, the vibrations and so on. We will have payload simulators to simulate the mass. We will have small electrical heaters to simulate the power draw in the thermal environment. And we'll collect the data from various points within the payload carrier. We'll have accelerometers at every corner so that if the structure is flexing, we'll be able to show you that. If the vehicle is in rotation, there'll be a differential in the acceleration rates at different points in the carrier, so you'll see that as well. So you'll have lots and lots of data on which to base your experiments when the actual when the experiments start to fly. And of course, we'll make this available to other people at the Flight Opportunities Program as well, so that their experimenters will know what to expect.
Yeah, that's a real advantage. Hang on to that, Brian. I was just going to ask a question of Alana. Thinking about, you're coming from the microgravity biosciences realm here. That's the way I'm viewing you. With that kind of capability and that kind of data, what kinds of questions would you have if you were flying, say, a small payload on one of these kinds of containers, and pre-flight, post-flight needs or anything of that sort that might be important for people to think about on these kinds of flights?
Yes, as actually this also relates to a previous question about when the power is getting turned on and when do you monitor microgravity. What I would one of the questions that I would monitor in my experiment would be also the transition from hypergravity to microgravity. So it's really great that the power is provided at the beginning of the flight. The other thing is you want to correlate everything with your, if the radiation measurement is being monitored or humidity or anything like that, you want to make sure that you include that. So that's the question about, relating your experiment to what's happening on outside. That's really, really important. The kind of questions are also related not just to how your payload behaves, but how your payload does not behave. And the power of negative data is really, really important. I think the power of what's happening here is actually the large amount of data that is going to be produced. And there's a lot of testing, and I think someone mentioned yesterday there's going to be a lot of mistakes that are going to happen. Those are not mistakes, they're actually learning experience for everyone. And if the database that maybe Make Magazine or whoever is going to provide, you want to be able to provide that information to everyone so they won't repeat the same thing. And I think that's what Ed mentioned, come up with something new, but it's also what you provide is going to be new for someone else down the line. So the kind of questions that you're going to ask, what's really, really important is to measure every single parameter. So, it is citizen science, but it can be very rigorous citizen science that's a benefit to everyone. So I'll be careful about monitoring everything and making sure, one of the things that's really important to me ahead of time is making sure you test your payload ahead of time as much as you can on the ground. Because you want to make sure you're actually subtracting the factors. I think there was a note yesterday about how to design an experiment in which you are able to cancel everything else, for example, other than microgravity. You might want to think, can I do that? How do I address that best in my experiment? How can I isolate every single factor so I can troubleshoot? One of the beautiful examples yesterday was on the 3D printer and how they were troubleshooting every single aspect, but you want to be able to, in your experiment, you're isolating parameters. So those are questions that are really important to address in an experiment.
That's great, thank you. You're next, I got you. Brian just wanted to make a comment on an earlier question.
Yeah, as you mentioned, it's really important to track all of those different parameters and to track all the data during the experiment. And Ed, as you mentioned, you're going to do this during test flights for the X-Core. You're going to have this very comprehensive data collection, and you'll be able to profile at least a test flight. So when the Lynx goes into operation, you will not be having all of that extensive instrumentation on board, and you'll now just have hopefully a full stack of payloads. Will each payload in itself, let's say that each payload would like to collect accelerometer data, would each payload need an accelerometer itself, or is there a plan for the Lynx Cub payload rack to have the basics at least on board the rack, or how will that work? Will there be a time history data sample from the X-Core Lynx itself post-flight that they can pull out of the avionics bay? How would an experimenter collect accelerometer data post-flight if they didn't have one on their in their experiment, or is it even possible?
Okay, yes, you will be able to get access to the Lynx avionics data post-flight. X-Core will provide that to you, so you'll be able to get the GPS and flight profile data after the flight and correlate that with the data that you've collected. But in terms of accelerometer data, if you want accelerometer data for your experiment, you really want to have the accelerometer as close to your experiment as possible. Because, if you look at the Lynx as just a rigid body and only consider translation, then theoretically the G-force should be the same at all points in the vehicle. But in actuality, the vehicle is not only going to be translating, it's also going to be rotating So you're going to have differential g-forces at different locations in the vehicle. And in addition, you know, it's possible that the vehicle and the payload carrier may also be flexing to a certain extent. So to get the best possible accelerometer data, you really want to have the accelerometer as close to your payload as possible within the same container. And the reality is, if you look at these accelerometer chips today, which cost almost nothing, they weigh almost nothing, they draw almost no power, there's really no good reason not to have one of those in your experiment if you need accelerometer data.
So let's take the Ardulab for example. There's no accelerometer on here. And if you were to take a basic Arduino and stack that with an SD card shield and an accelerometer and then maybe some other sensors, that would actually probably fill an entire 1U. Is there any plan, as you mentioned there's going to be a 1U and a 2U capability for the links, would there be the capability to do like a 3U or a 4U? Because I foresee the possibility that if you're stacking an SD card and maybe a motor driver and now an accelerometer, that would fill maybe 1 or 1.5 U's itself.
Is there a capability to do that? Absolutely, yes. The Lynx Cub payload carrier, which we're developing with the Space Engineering Research Center and the Department of Industrial and Systems Engineering at Texas A&M, is designed to accommodate up to 6 3U containers. But the way we intend to fly it for our program would be with 6 2U and 6 1U containers, so that we can carry 12 payloads per flight. And the reason we're doing this is because, you know, we want to encourage people to build and fly as many payloads as possible. And we also want to keep the costs down. And the smaller a payload is, the cheaper it's going to be on average, all other things being equal. So that's the way we intend to operate on our flights. We put together a number of payloads on paper, and it's really, we feel that you can do a lot of interesting stuff within a 1U or a 2U container if you think cleverly, and if you look at the sort of hardware which is out there. It's a little bit frustrating sometimes when you see the number of pieces of hardware which will almost but not quite fit within a 1U CubeSat. I think there will be a lot of experiments which probably could fly in a 1U container by weight, but by volume we'll actually need the 2U. But I think that there will be a good mix of 1U and 2U experiments. And you know, if you do need to go to a larger container, you know, there are other programs such as Flight Opportunities out there, which I'm sure will be making those things available.
Thanks. Great. I'm going to get some of these questions. The audience is getting restless out here. I'm ignoring you.
I have a microphone. Hello? Yeah, I understand that there's a maximum power draw, simultaneous power draw for all the experiments collectively. Is it the case that some experiments don't need to be on the whole time, so it might be advantageous to pre-plan a program on and off so that some experiments could use more than their fair share of power if they're then sequenced off? You know, like you probably need a heuristic program to figure out the right sequencing to maximize. Is that feasible?
Or justified?
Oh.
Okay, well, once again, you know, we expect that the power will be turned on just prior to flight, but you know, the fact that the power is turned on does not mean you necessarily have to be drawing all that power. You know, when you use the power is up to you, and you know, I would suggest that you not be wasting it. You know, don't actually plan on drawing the power until you actually need it. As far as actually coordinating with all the other experiments and having some sort of planned schedule for when people are going to be drawing power, that would be very difficult due to the number of experiments that are flying on the flight and the fact that you know, we won't know exactly which payloads are manifested until fairly late in the process, because we have an awful lot of factors that we're going to have to juggle. On the top level, you know, basically we'll be first come, first serve. You know, the people who get their hardware into us sooner will have a chance to fly sooner. But on the secondary level, there are going to be a lot of modifications to that because, we have to consider things like thermal compatibility. If there's an experiment which is creating an awful lot of heat that needs to be dissipated, it might not be possible for that experiment to fly on the same flight as a biology experiment where you have critters that are going to die if they get too warm. We may have experiments which require a certain customized flight profile or that need to fly during a certain time of day or a certain time of year. So we have all these factors that we're going to need to juggle. So it's going to be very difficult for us to predict in advance who you'll be flying with. Therefore, you're going to need to be as flexible as possible. We have the 100-watt limit for all of our payloads, which we'll be dividing by the 12 payloads in the vehicle. So, you can divide 100 by 12, I'm sure. If not, you probably have no chance of building anything that actually flies. There's also the 200-watt thermal limit. Again, that's divided by 12 payloads, and that accommodates not only the power that you're drawing from the X-Core vehicle, but also any batteries that you have, as well as any biological or chemical processes that are generating additional heat.
Great, I know there's some more questions. I want to get one thing in here that related to an earlier question. I think got lost. The Flight Opportunities about results, sharing results. The Flight Opportunities Program being a government program requiring final reports needs to share those results. So we're working on that, and that's not easy. But that's beginning to happen. Just a little advertisement here for some earlier work that I did when I got involved with NASA Life Sciences back in the dark ages. Its view was that investigators were totally responsible for reporting their results. And I mean totally. Published, whatever. NASA had no particular interest in those results, no capabilities to handle them. So we got involved and found a few champions in the agency where we captured all of the mission descriptions, science objectives, research objectives, technology hardware descriptions with real drawings, not photos of hardware, real diagrams with labels, science results and publications, 1965, 2003, all of NASA's biosciences, KSC, Ames, etc. A 9-year effort and ran out of money in 2003. And the whole motivation was, I think, maybe what was behind your question. Especially with the Citizens in Science program, especially with an open source kind of activity, and there's a Life Sciences Data Archive in NASA that also is a way to share this with human research and all of that, and I was involved in that as well. So it's really important, I think, to somehow figure out ways to share that information. As far as I know, the microgravity university program that flies on the reduced gravity office program, flies on the parabolic aircraft, an incredible program, it's been going for years, has wonderful profiles of the objectives and photos of the technology and stuff, but I don't think they capture results. So it's a big issue, and I would encourage, especially the citizen science program, to somehow share that information, because then you just build on it, and it's just it's a great thing. Anyway, yes, another question.
I have a question about the kinds of experiments that are planned.
Oh, go ahead. I didn't see you back there. Sorry.
So, what ideas are out there for the experiments in terms of experimental design, in terms of scientific areas? Could you maybe give some examples for that? And also, are you focusing on certain areas like astrobiology, for example?
You want to? There was a lot of discussion yesterday. You were probably not here yesterday. Okay, big discussion yesterday on that topic, and I think that's a question that's going to have to be handled outside this discussion here, which has got to be faster. But it's a great question. I'm happy to talk to you about it. I'm sure Juana can also cover that. It was covered by several people. Yes.
I need a moderator.
Brad Wall from Embry-Riddle. I just want to know what kind of things are off limits. I know that the CubeSat project, you can't do pyrotechnics. What else can't you do acids or whatever. I just want to know what kind of things are off limits.
Like microbial experiment.
Who wants to handle that?
Okay, well, there are basic safety requirements that are published in the X-Core Payload User's Guide. So you can look at that as a starting point. Obviously, anything which X-Core is not willing to fly, we are not willing to fly. We cannot override their safety requirements, and we would not want to. If for no other reason than the fact that our puny pink bodies are going to be on board the vehicle. Additionally, we are a citizen science project. We are an open science project, so we do have this commitment to open source within the general guidelines, which I discussed. So if your experiment is proprietary, if you want to keep the data to yourselves and patent it and never tell anyone else what you're doing, we aren't necessarily opposed to that, but that's not what we're about, and that's not the sort of experiment that we want to fly. So we are very committed to the principles of open science. We think that this is getting back to the way science is theoretically supposed to be done. We want to see people sharing their information and making it available to other people so that other people can replicate their experiments. And we're hoping that some of these experiments will actually be picked up and followed on by professional investigators as well as citizen scientists.
Great. There's another question there. They have a microphone.
A quick question about the outside payload compartments. One, are they going to be available to the Citizen Space program, or are we just talking about, payload bay A or as it was designated? And do they have power if they are going to be available?
Yes, they do have power. You can find the specifications in the X-Core Payload User's Guide. I don't remember what they are offhand. And yes, we do expect that they will be available. However, there are only 2 aft cowling ports on the vehicle, so we only have the capability to fly 2 experiments there, whereas we can fly 12 payloads internally. So that's why we're really emphasizing the internal payloads at this time in this workshop, because there are going to be a lot more flight opportunities there. It's a factor of 12 to 2. We also have a $10,000 cash prize for one particular experiment, the High Altitude Astrobiology Challenge, which does need to fly in one of those aft cowling ports. So, if we get good hardware for that, we would anticipate that we would fly that experiment on all 10 of our missions, so that, that takes up one of the 2 available aft cowling ports, which still leaves another port, so, there is an opportunity to do other things as well.
I have a follow-up about that. The aft cowling ports, will they be exposed to, will they come out of the ship at all? Can they see UV radiation or atomic oxygen, or do they just stay internal and just see vacuum?
Who wants to handle that?
The aft cowling port is exposed to space. It is not vacuum tight, so it will see ambient pressure and temperature at all points during flight. There's also a hatch which can open at a specified point during the flight. So at that point, you can look out through a sensor. You can extend a boom or probe of some sort. You can also optionally eject a payload. There is a spring-loaded mechanism for ejecting payloads, in which case, of course, you need to provide your own recovery system, which is presumably a parachute, although it could be something else in theory.
Okay, we got a bunch of questions here. I'm trying to be fair and follow. There's one. Thank you.
So my question, sort of, Ed just. Can you guys hear me? Okay. My question relates to something Ed just touched on, and we've sort of been bouncing around about it. It has to do with the fact. So I'm a researcher. I work at a university. You're a researcher. You do research. You touched on using water bears yesterday, right? You're really promoting it. Is there a good way right now to tie researchers to the citizen science community? Are we going to have some sort of website where people can get in touch with each other, both pre and post developing these payloads, so that people who are like, I really want to do something, I really want to put something on the orbital vehicle, we all do, right? But is there some way to say, okay, well, let's tie that to research, and maybe we can can get a paper out of it. Like, right? I appreciate having more people help me do my research. Or, and I know that like if you have a payload up there, it'd be awesome to say, and this helped a researcher. We helped learn something new about the universe, right? So, is there a way to sort of tie us all together right now?
At the moment, what we have is our citizensInSpace.org website, which does have some of those capabilities you're looking for. I mean, not all of them. We'd like to expand what we have to offer. And, you know, if you like to contribute something to our website, we would love to have people contributing to it. And we also have some email links there to get in touch with people and to ask us questions. We don't have a good forum for exchanging information at the moment. That's something we would look to add in the future. Or if someone else already has a website that has these sort of capabilities and would like to partner with us, we'd love to do that as well. You know, we're not necessarily committed to doing everything ourselves, and quite frankly, you know, we'd like to push as much work onto other people as we possibly can. We're lazy.
So, I mean, so a lot of you work with student groups, right? So what experience do you have doing that, and how do you think you could help others do that as well?
Yeah, I guess that's an excellent question because it comes down with well, how much work you want to put on someone else's shoulders and how much work you want to take on yourself for free. So it really comes down to two sides of the question, right? If citizen science are interested in an experiment, the number one thing to do is think of what you want to do, how you want to approach it, and find the expertise that has that, and then ask the question. So you make sure your experiment is new, you make sure your experiment is to really the highest possible standard. Now on the other side, of course, researchers is, it can be very beneficial for us to have the help. There's, for example, here in the audience, a research club established at the American River College. There's tremendous expertise in the audience as well on the other side on the researchers, so I really appreciate the questions on linking. You know, it's up to each person to decide how much they want to ask from the citizen science side and from the researchers how much time they can spend into this. So the more the citizen science came up with a really good mature payload, the more the research community is going to be interested. So it comes down to talking and I think troubleshooting this link. It's a start, so it's coming down to really a collaboration. It's not, I don't think it's, in my opinion, it's not one or the other. It's one or the other and both. So whatever collaboration system works.
Okay, yeah, okay. Hang on, Doug. You're next.
Yeah, so at Infinity Aerospace, we're specifically concerned about supporting the Ardulab and the users of the Ardulab, but we're also very interested in building the community that you're talking about. We actually have a forum linked directly from our website that we intend to support all microgravity researchers and get everybody together to collaborate, share knowledge, and build sort of this empire of knowledge where people can build more advanced and more advanced payloads with less and less work. And so if that's something you're interested in doing, we have software capability at Infinity Aerospace, and there's definitely come talk to me about that because that's something we're really interested in doing.
What's the site link for that?
It's ardulab.com/forums or community, I think. It's directly from ardulab.com. If you click on community, you can get directly to it.
Is that going to be like a sandblast style collaboration?
We actually, so we do have the Ardulab on Sunglass, so you can actually see the whole model and take measurements right online. You just make a Sunglass account and go right to our model. But it's just a typical forum that you find directly linked from our website. And we're still really building that up, and obviously this new space movement is pretty immature at this point. So we're hoping that we can work with groups like hers to really kickstart that and bring a community together that's building on top of each other.
Great. I'm going to switch to Doug Messier here. He's got the mic.
I think the previous questioner asked my question, so I'll skip to another one. Have you talked to anybody at NSTA?
Can you speak up just a little, Doug?
Have you talked to anybody at the National Science Teachers Association about collaborating on some formal educational things for teacher guides and things like that?
I'll just tell you what my experience has been. NSTA is an interesting organization. But they're a large national group with the headquarters just outside the Capital Beltway, and They have a lot of professional employees. They're not always necessarily the easiest people in the world to work with. This year, one of our people was actually working with NSTA to supposedly set up a number of emerging commercial space companies, including XCOR, to have free tables and to present at their annual aerospace banquet at their big conference in San Antonio. And basically, they never got back to us. A month before the conference was taking place, we still hadn't heard anything from them. And we don't know why. There's no transparency. And so, we'd love to work with NSTA. We're not sure to what extent this will happen in the future. But there are also other science organizations around the country. In Texas, we have the Science Teachers Association, which runs the CAST conference, Conference for Advancement of Science Teaching. It's a regional conference for the state of Texas. It used to be there were 20,000 teachers a year that showed up at the NSTA Science Conference from all over the nation. In the last NSTA conference, they're now down to 9,000, whereas the CAST conference has grown to 7,000 or 8,000. So you have almost as many teachers from the state of Texas attending the CAST conference as you do nationally for NSTA. So, right now, plus the fact that CAST charges us less than half as much to exhibit at their conference as NSTA does. So it's becoming harder and harder for us to justify working with NSTA financially.
Yeah, well, I used to work for them, so just be patient and get your own
Speak up a
stuff.
little, dog, I'm not hearing you.
Yeah, I used to work for them, so I understand some of what you're saying. Just be patient, get your stuff together, get moving on that, and then you'll be in a better position in a few years to really work with them, and you'll be able to offer them more.
I think Luana had some comments she wanted to make.
Yeah, there's a model that I'm more aware of that works really well. Instead of working necessarily directly with the teachers, you work with an organization that works with the teachers, and the model is that of Orion Quest. It's based out of Michigan. There are two former teachers who built this community, and I have access to 25,000 schools in the US. And what they do, they work with bioserves and other companies and actually provide data from the ISS, the real scientific data, and put it into the classroom. So there are two ways of thinking about this communication with the teachers. Is either teachers and students build their own payloads, but also for US citizen science, if the database is available later on, is put it into the schools and have the students and teachers help you out. For teachers, part of the reason they don't respond very easily, I've had a lot of experience with this, is not because they don't want to, it's simply because they don't have the time. Time constraints are huge on teachers, so if you have some sort of interface, that's really, really helpful. It's not the unwillingness, it's the lack of time, but the entire student community can build, the entire education community in the US can benefit tremendously after what you're doing right now. So, having access even to the data from the payloads, even if they don't get to build their own payloads, it's a tremendous learning experience.
Okay,
Let me add something.
Okay. This is good, we could do this in a long time.
This is a technical thing about the accelerometers. Sorry, I didn't add to that. Maybe it's worth adding accelerometers to a Cub, so it provides the data to payloads inside, so you can actually fit stuff into one U without adding more and more sensors to it. So links will not provide information, but the Cub will provide, well, hopefully. I'm not designing the Cub, so I cannot be involved in that. It's just an idea.
Some shared measurements, I'm sure will probably emerge from this. Yeah, Vaughn Kegel.
Thank you, Richard. I know you're trying to wrap it up, but just a closing comment, and it was touched on earlier, and I just want to really spotlight it and really emphasize how important it is. First of all, shout out to water bears in space. There we go, yeah, let's hear it. They can live 100 years. I mean, there's just so much that they've got going for them. I mean, when it comes to body mass distribution, they totally are going to be on my radar. So let's see, but I can't emphasize enough that in the NASA, shuttle program, that we've been able to do a lot of research with microgravity, and this is going to be such a one thing that we haven't really been able to touch on in launching things in space is that crews tend to be, strapped down during launch and during re-entry. So the opportunity to really activate and even participate in some way with the transition zones, having payloads go into microgravity and coming out of it, and being able to get a snapshot or a video or a trend of that is really pioneering. It's something that we haven't had insight to before. And you talk about transparency, that is really exciting when you come to biospecimens, fluidics, even some solid mixing and things. So don't underestimate the power of learning and transformation that's really going to occur, being able to finally access those transition phases of flight.
So, great panel. Thank you so much. Great questions coming from the audience. These folks are going to be here, so we will continue this. And we